Chapter 1.4.2.3 Stateful Sets. Stateful set is an API object used to manage stateful applications by deploying and scaling a set of pods while maintaining guarantees about ordering and uniqueness. Unlike a deployment, stateful set ensures each pod has a persistent identifier that remains even during rescheduling. This allows for easier replacement of failed pods by matching existing volumes. Stateful set is useful for workloads requiring storage volumes for persistence. It provides a way to manage stateful applications in Kubernetes effectively. Using stateful sets. Stateful sets are useful for applications that need stable network identifiers, persistent storage, ordered deployment and scaling, and automated rolling updates. These features ensure that the application remains consistent and reliable across pod rescheduling. If an application does not need these specific requirements, it can be deployed using a workload object like deployment or replica set, which are better suited for stateless replicas. These options are more suitable for applications that do not require stable identifiers or ordered deployment, deletion, or scaling. Limitations. Stateful sets require storage provisioned by a persistent volume provisioner or an admin and do not delete volumes when scaling down. A headless service is needed for network identity, and stateful sets do not guarantee pod termination upon deletion. To gracefully terminate pods, scale down to 0 before deletion. Using rolling updates with the ordered ready pod management policy can lead to a broken state that may require manual intervention to fix. Data safety is prioritized over automatic purging of stateful set resources. Components. The example provided illustrates the components of a stateful set in Kubernetes, with a recommendation to use the read-write-once pod access mode instead of read-write-once for production. A headless service named Nginx controls the network domain, while a stateful set named web specifies that 3 replicas of the Nginx container will be launched in unique pods. The volume claim templates provide stable storage using persistent volumes provisioned by a persistent volume provisioner. The name of a stateful set object must be a valid DNS label. The pod selector must match the labels of its template for proper functioning, and failing to do so will result in a validation error during stateful set creation. The volume claim templates field can be used to create a persistent volume claim for stable storage. Additionally, the spec.min_ready_seconds field specifies the minimum duration a newly created pod should be running without any containers crashing to be considered available, aiding in the progression of a rolling update strategy. Pod identity. Stateful set pods have a unique identity that includes an ordinal index, a stable network identity, and stable storage. The ordinal index is a unique integer assigned to each pod in the stateful set, starting from 0 up through the number of replicas. The spec.ordinals field allows for configuring the start ordinal of the pods. The stable network identity of each pod is derived from the stateful set name and the ordinal, with the host name being in the form of stateful set name-ordinal. This can be controlled using a headless service. The stable storage aspect involves each pod receiving a persistent volume claim for each volume claim template entry, with the ability to specify a storage class and provision storage amount. The volume mounts associated with the persistent volumes are attached to the pods when they are rescheduled onto a node. It is important to note that persistent volumes associated with pods' persistent volume claims are not deleted automatically and must be done manually. Additionally, when a pod is created by the StatefulSet controller, it is labeled with statefulset.kubernetes.io/pod name, which can be used to attach a service to a specific pod in the StatefulSet. A pod index label, apps.kubernetes.io/pod index, is also added to each pod, with the value being the ordinal index of the pod. This label enables routing traffic to a specific pod index, filtering logs and metrics, and more. It is necessary to have the FeatureGate pod index label enabled, which is enabled by default as of Kubernetes v1.28. DNS lookup for pods may be delayed due to negative caching, and there are options to query the Kubernetes API directly or adjust the caching time in the DNS provider to discover pods promptly. Overall, StatefulSet pods have unique identities that provide stability and consistency in terms of ordinal, network, and storage aspects. Deployment and scaling guarantees. A StatefulSet with n replicas deploys pods sequentially from 0 to n-1 and deletes them in reverse order. Before scaling a pod, all of its predecessors must be running and ready, and all successors must be fully shut down before termination. It is unsafe to specify a pod spec termination grace period seconds of 0 and is strongly discouraged. If a scaling operation is applied to a StatefulSet, the pods will be terminated in a specific order. The default management policy for StatefulSets is ordered ready, but it can be changed to parallel to allow for parallel launching or termination of pods during scaling operations. This does not affect updates. It is possible to relax ordering guarantees while preserving uniqueness and identity guarantees via the .spec.pod management policy field. Overall, StatefulSets provide control over the order in which pods are deployed and terminated to ensure proper functioning and reliability of the application. Update strategies. StatefulSets in Kubernetes have a field called .spec.updateStrategy that allows for the configuration and disabling of automated rolling updates for pods. There are two possible values for this field: onDelete and rolling update. When .spec.updateStrategy.type is set to onDelete, the StatefulSet controller will not automatically update pods, requiring users to manually delete pods to reflect changes made to the StatefulSets template. On the other hand, the rolling update strategy automatically implements rolling updates for pods, making it the default option. This allows for smooth and controlled updates across the StatefulSet. Rolling updates. The text explains the behavior of a StatefulSet in Kubernetes when the .spec.updateStrategy type is set to rolling update. In this case, the StatefulSet controller will delete and recreate each pod in the StatefulSet in order from largest to smallest ordinal. The control plane waits for each updated pod to be running and ready before moving on to its predecessor. The text also introduces the concept of partitioned rolling updates, where a partition can be set to update only pods with ordinals greater than or equal to the partition. Additionally, the text mentions the feature of controlling the maximum number of pods that can be unavailable during an update using the .spec.updateStrategy.rollingUpdate.maxUnavailable field. This can be set as an absolute number or percentage, with the default setting being 1. Furthermore, the text discusses the possibility of a forced rollback in cases where a pod template update results in a broken state that cannot be automatically reverted. In such cases, manual intervention is required to repair the StatefulSet by reverting the template to a good configuration and deleting any pods that were already attempted to be run with the bad configuration. Overall, the text provides an in-depth explanation of how StatefulSets behave during rolling updates and how certain configurations can be used to control the update process and handle potential issues that may arise. Persistent volume claim retention. The new feature in Kubernetes v1.27 beta allows for the control of persistent volume claims, PVCs, in stateful sets through the .spec.persistent volume claim retention policy field. This feature requires enabling the stateful set auto-delete PVC feature gate on the API server and controller manager. Two policies can be configured for each stateful set, when deleted and when scaled. Delete policy deletes PVCs when pods are deleted, while retain default retains PVCs when pods are deleted. These policies only apply when pods are removed due to stateful set deletion or scaling down. The default policy is retain, maintaining the current stateful set behavior. The example policy demonstrates how the controller adds owner references to PVCs so that they are deleted by the garbage collector after pods are terminated. The when scaled policy deletes PVCs only when a pod is scaled down, not when it is deleted for another reason. If a pod is condemned and marked for deletion, it is first set as an owner to the associated stateful set template PVC before being deleted. The .spec.replicas field specifies the number of desired pods in a stateful set, defaulting to 1. Manually scaling a deployment will be overwritten if the stateful set is updated based on a manifest. If a horizontal pod autoscaler is managing scaling for a stateful set, do not set the .spec.replicas field, but allow the Kubernetes control plane to manage it automatically. It is recommended to wait for the controller to come back up if pods need to be force deleted to ensure proper owner references on PVCs.